So, what are variables in Python? Now, uh, whenever we want to store something in memory, right, or in computer, we need to access memory, right? Now, for example, if you are writing a program to add two numbers, right? So when user enters those two numbers, you will need to store those numbers. Now the question is, where will you store those numbers? So you will store those numbers in computer memory. Now, how will you access that memory, right? So it is, memory is byte addressable. Now, if you are able to break open the memory, if you break open the memory, you know, there are locations in memory, right? There are locations in memory, and each location is called a byte. Each location is called a byte, and each location has an address. Right? For example, this is the location. So this location is 1 byte. So this location has an address, right? So each location has an address. Now, if you want to store something, we store that data in those memory locations or in those bytes, right? Now it is very difficult for us to access those bytes or that memory, to access that memory by using memory addresses. So what will you do? Because these memory addresses are very long, very, maybe sometimes hexadecimal, right? So it is beyond our scope to access memory by using addresses. But ultimately, we need to access that memory. Ultimately, we need to access that memory because we want to store something in that memory, right? Now, how do we do that? How will we do that? So what we'll do is we'll give names to those memory, right? Rather than remembering or rather than accessing memory by using the addresses, right? Memory addresses, we'll give names to those memory addresses. Now, for example, if I know this memory location has name A, then I can say that A is equal to, let's say, 10. I can say that if I know this memory location has name A, so it is very easy for me to say A is equal to 10. That means I am storing 10 in that memory location. Now, what is that A, right? How will I give that name to this memory location? So we need not give that name. So we simply need to tell compiler, I want I want to store this 10 in a memory location, and please name that memory location as A, right? So we tell compiler to name a memory location by by using some name, right? For example, A. So we ask compiler to name a memory location with some name, right? For example, A in this case, right? So that later I'll be able to access that memory location by simply using that name. I did not care what is the address, memory address, right? So we ask compiler to name a memory location, right? We don't name ourselves, right? But we ask compiler to name a memory location, right? So compiler gives a name to that memory location, right? Now, which memory location? Whichever memory location is free, to that memory location, compiler gives a name which we have asked compiler to, right? For example, A. So now the name which compiler has given to that memory location is called as variable. This A is called as a variable, right? This A is called as a variable. All right. So now later I can simply say A is equal to some value. So for example, here you can see here. So this A is equal to 10. A is equal to 10. So this A is called as a variable. A is called as a variable, right? And we are storing 10 in that variable or in the memory which is named as A. So here this memory is named as A. So in that memory we are storing 10. Right? Now, in many programming languages, the variable has a data type, something called as data type. Data type means what type of data you can store in that variable is called as data type of that variable. The type of data which you can store in that variable is called as the data type of that variable. But in Python, for example, in C, if you want to store integer, you will create a integer type variable like this, int A. So in C, what is the meaning of this? The meaning of this is we are telling to the compiler, reserve a memory location, name it as A, and in that memory location I want to store integer, right? I want to store integer. That means the type of that memory location, uh, uh, is integer. So by with this type, the number of bytes reserved for this variable a depends on the type of that variable a. The number of bytes will be reserved for this a will be dependent on the type of this variable a. For example, in C, let's say we require 2 bytes to store an integer. So this memory location a will be of 2 bytes. That means continuous 2 bytes will be named as a. Okay. So, but in Python, we need not give this data type. We need not give this data type, right? We need not declare the variable with type. We can directly use the variable. In C, if you are using a variable, you need to declare it first and then you can use it, right? But here in Python, we need not declare it. We can directly use it. We can directly use it. As you can see here, this a is equal to 10. We did not declare this a before. We're directly using it. We can directly use it, right? So that is a variable. So the bottom line is a variable is nothing but a name given to a memory location. Variable is nothing but a name given to some memory location, right? And why we need to give it name to the memory location? Because we want to access memory, right? And memory has the addresses, so we cannot access memory by using the addresses. So we need to access memory by using the names, which are human readable, right? So that's why we require variables, right? Now here this a is a variable in which we are storing value 10. Now you see b is another variable in which we are storing value 5.5. Now you see this 5.5 is float, this 10 was integer. So that means a is integer type variable, b is float type variable, right? In C we are storing a string. In C variable, this is another variable C in which we are storing a string called as ml, right? So this C is the string type variable, right? Now if I execute this, you can see here, right? So this what we did is we printed a. In Python, if you want to print the value of a variable, we say print name of the variable, right? So print a. Now with this, what happens internally is compiler reserves some memory. With this line I'm telling, what happens internally is compiler reserves some memory, and that memory will be named as a, and this is called as an assignment operator. We are assigning 10 to this memory location a, so 10. Now later, when we use a, we are actually referring to this memory location which is named as a, right? So we are accessing that memory location. So we are printing the value in a. The value in a is 10. So you are now, if you want to print that memory address, right? Memory address which is named as a. So we can print it by saying print ID of a. ID is nothing but memory address of a. You see, this is how long this long is the memory address of a, and it's not possible for us to remember this memory address, even though somebody tells this is the memory address of, and you need to access that memory address. So it's not possible for us to use this memory address again and again, right? You will need to frequently access memory. So it's not possible for us to access the memory by using the memory addresses. So that's why we'll require memory to be named as by using the names which we humans can read. Okay. So now how can we assign the multiple values to the variable? You see here, here I have 3 variables, a, b, c. So here on the same line we are assigning these 3 values to these 3 variables a, b, c. So a gets 10, b gets 5.5, and c gets ml, right? So a, so this now you see, if we use this a equal to b equal to c equal to ai, this ai is assigned to all these 3 variables. Ai is assigned to all these 3 variables. Okay. So Now storage locations. If you see, if we have this variable x, so what will happen is some memory location will be named as x, and in there we are storing 3, right? And then later, if I want to print the memory address of that x, I'll simply say id of x. So this is the memory address of this x. Similarly, now if I want to store, if I want to store 3 again, right? So now here the name, the variable is y here, right? Y3, y is equal to 3. Already we have stored x is equal to 3. Let's say x is equal to 3 here, right? And this is the memory address 943004165342880. Right? Later, if I want to store 3 again in another variable, right? So in fact, what happens is we are again storing 3. So what Python does is it intelligently what it does, it knows already I have stored 3 in some variable called as x, or in some memory location I have already stored 3. So let's assign again another name to that same memory location y. That means y is also referring to the same memory location, right? Y is also referring to, x is referring to this memory location. Now y is also referring to the same memory location. That's why if I print the id of y, id of y, you will get the same address. You see, this address and this address are very same, because y is also referring to the same memory location, right? So now the idea here is x and y points to the same memory location, right? Now, if y has different value, right? If y has different value, let's say y is equal to 2. Now we are showing, now new memory location will be created. Now you see, this is the new memory location whose ID is this one, right? And this x is equal to 3, that ID is 280, it is 600, right? So the y has different value. When y has different value, y will not refer to the memory location which is referred by x, but a new memory location will be reserved, and that will be named as y, and there you will store 2. Okay, now what are data types, right? So every value in Python has a data type. So we saw that we have integers, we have floats, we have characters, right? So those are called as data types, right? So every value in Python has a data type. So since everything is an object in Python programming, data types are actually classes and variables. Variables are the instances of these classes, right? So data types are actually classes, and variables are the instances of those classes, right? So various data types available are integer, float, character, strings, etc. You see. Now let's say we have this numbers, right? So numbers may be integers, floats, or complex numbers, right? There are 3 types of number in Python: integers, floating point numbers, and complex numbers, right? So these are the numbers category in Python. So they are defined as int, float, and complex classes in Python, right? So there are types. So what is data type? Data type is a class actually in Python. It's a class, right? And their instances, the objects, right? So just a moment. So here data types are classes, and variables which we will create are the instances of those classes, right? Okay, so here there are 3 types of numbers: integer, float, and complex numbers. So here if we say a is equal to 5, now you see this 5 is nothing but integer value. This 5 is nothing but integer value. We are assigning that 5 to a. So what is happening with this statement is some memory location will be called as a, and there we are storing 5. So then if you want to print the type of this a, you simply say type of a, right? So this will print the type of a. So if I run this, so 5, a is nothing but 5, and its type is int actually. So this will be replaced by this line. So type of a is integer. So this type a will return this, right? So A is integer type. Now if I store A is equal to 2.5, so the type of A is changed to float because 2.5 is a floating point number. So if I run this, you will get type of A as float. So now if we say A is equal to 1.2j, so here this A is nothing but a complex number now. So print A is a complex number, right? So if I run this, so this A is a complex number. Now we are printing it. Is instance is one more function. Is instance is one more function. So is instance checks whether this variable or this value belongs to this type, right? So this 1 plus 2j, is it instance of complex? Yes, it is true, right? 1.2j is an instance of complex, right? So that is how these are the number data types in Python. So there is one more data type. There are many data types, but we are seeing we are looking at quite few data types here. Another is called as Boolean. So Boolean means a variable which will store either true value or false value, true or false. It's called as Boolean. For example, A is equal to true. A is equal to true. Now A is a variable in which we are storing whose value is true. A is storing true like this, true. So now what is the type of A, right? So the type of A is Boolean in this case. If we print the type of A, it will return Boolean. Now let's look at Python strings. Strings in Python. So what are strings? In fact, string is a sequence of characters. String is a sequence of characters. So a string in Python consists of series of sequence of characters. The characters may be letters, numbers, or special characters, right? So sequence of characters. So these characters may be letters, numbers, or special characters. Letters may be A, B, capital A, B, etc. Numbers may be 1, 2, 3, etc. Special characters may be dollar, pound, etc. Right? So a string can consist of any of these, or all of these, or some of these, right? Or any combination of this. So a string can be indexed, often synonymously called as subscripted as well. So we'll see what do you mean by index. You see here, here we have s as a variable. So as soon as I say yes variable, so we'll understand that some memory will be reserved, and in that memory, what will be stored? So this value, right? So this is a course on data science. This is a course on data science. So this yes is this string now, right? So if I print yes, I'll get. So this is a course on data science. So this is the value of s. This is the value of s. What is the value of s? This is this string, right? Now, in fact, so this location, this string is stored like this. In fact, it's sort of an array, right? So this, the T, H, I, S, so on and so forth. That is how this string will be stored actually, right? So this location will be called as 0th location in the string, location number 1 in the string, 2, 3, and then after this yes we have space, right? So this space will be 4th location. Then we have I here, I will be 5th location, so on and so forth, right? That is how this string will be actually stored in yes, right? Now if you want to access this T only, if you want to print only this T, you will simply need to say s of 0, s of 0, yes, for this string, and 0 is the index or location on which this T is stored, right? So s of 0. So s of 1 will give us H, s of 2 will give us I. Now if you want to access the last character of this string, you will say s of -1. This is one way to access the last character. There is another way to access the last character, s of length of s. Length is a function which will return us the length of this s, right? So length of s will return us the string, right? So s of length of s -1 will also return us the last character of the string, which is in this case is e, right? So if we execute this, so t, right? So we'll get t. Now I can slice, I can create the slices. I mean, I can access part of this string, How can I access? Let's say I want to access this string from this I onwards, only this I onwards, right? I want to access, I want to print only this string. I want to print only this string is a course on data science, right? I want to only print that. So what on what location this I is? I is on, this is the location 0, 1, 2, 3, and the space is fourth location. I is fifth location, right? So from fifth location onwards, I want to access this. I want to print this string, right? So on fifth location, right? So in string yes, fifth location, this 5 stands for fifth location, fifth colon, nothing here means all the locations starting from 5, all the locations starting from 5. So s of 5 colon will print all the locations, all the characters starting from location 5 onwards, right? So location 5 is I. So you see, I is the course on data science. So s of 5 will print all the characters starting from location 5. This is called as slicing. Okay, so let's see a few more. So that is how we create the slices of the string. Right? Now there is another type of data type, or another types of variable, other types of variable called as list. So we can create variables of list type. Right? So what are lists in Python, right? So list is an order sequence of items. So this list is an order sequence of items. It is one of the most used data type in Python, right? So one of the most used data type in Python. So now those who are familiar with arrays in other programming languages, they might understand, right? So these lists are quite similar to arrays. Only thing is, in this list we can store heterogeneous data. Heterogeneous means all kind of items we can store in this list. You see here I'm storing 10, which is integer, this 20.5 which is float, and this hello is a string, right? All of that is being stored inside a single variable called as a. So here a is a variable which is a list type variable, Inside this a, I'm storing 10, 20.5, right, and then hello. So all of that is stored. That's why this is called as heterogeneous data. Integer, float, string, all is being stored inside a single variable. That's why list is a heterogeneous data type. So now you see here, this a is a list. That is how we create list. So a is a list. So, and what is the value of a? 10, 20.5 hello, right? So now, so this in list, this location is called location 0, this location called as location 1, this location is called as location 2. So if you want to print only location 1 data, you will say a of 1. A is the name of the list, and 1 is the subscript or index, right? So a of 1 will return us the value on location 1 or index 1 or subscript 1, right? So this 20.5, so this will return us 20.5. So lists are mutable, meaning you can change the contents of the list. For example, you are storing 20.5 on this location. If you want to store some other value, so you can simply say a of 1 is equal to 30.7. Now the list is changed. Now you can see the list is changed here. So 10, 30.7 and hello, right? So when you are able to change the contents, this is called as mutable data type, right? So contents can be altered. Now tuple is one more data type in Python. So you can see here, tuple is quite similar to list, right? Only thing is we create list by using these squared brackets. So we said a is equal to this. Now if you want to create a tuple, we'll say a is equal to this. Round brackets, right? Now P is a tuple here which contains 1, 1.5 and ml. So 3 things, right? So if you want to, again, this is location 0, location 1, location 2 inside the tuple. Again, there are indices to the tuple similar to the list. Again, in order to access the elements of the list, you will say tuple, you will say name of the tuple and index, right? So T of 1, 1.5. Okay. So T of 1 is 1.5. Now the primary difference between a tuple and the list is tuples are immutable, whereas lists are mutable. Tuples are immutable. That means you cannot alter the contents of the tuple. So you cannot say T of 1 is equal to 1.25, right? What you are doing by T of 1 is equal to 1.25, you are trying to store 1.5 in location 1, right? Which is not possible in tuples because we cannot change the contents of the tuple. It's not possible. That's why you see we are getting, for this line you are getting this error. So let us run this. So this is tuple T. If we print T of 1, we will get 1.5. Now we will try to change the contents of location 1. So T of 1 is equal to, so we are getting tuple object does not support item assignments, right? Okay, so there is one more data type in Python called as set data type, right? So set, we have seen a list which we create by using square brackets, immutable data type, and tuples we create using round brackets, immutable, and there is something called as, so list and tuple both are ordered data types. Order means items are ordered here, right? So set is another collection of items which is unordered items. This set is unordered items, right? So if that is how you create a set. A is equal to this curly brackets here, and inside the curly brackets we store the items of the set. So here you see we have stored A is equal to 10, 20, 10, 30, 20, 45. If you print A, you will not get in the same order which you stored, right? You will get this. You will get this. That's why this is unordered collection of items. So this set is unordered collection of items, unlike list and tuple. So as it is unordered list of items, you cannot access the contents or items in the set by using the subscript or indices. So A of 1 or A of 2 is not possible for sets. So you see here S of 1, we try to access here S of 1. So this is not possible here. We will get an error. Right? So if you want to, this A is type. A's type is set. Similarly, if you want to print the set, you simply say print S. Right? That will be printed. So just a moment. So here. So here we had this A as set. We can perform set operations like union. So one of the main use of this set data type is we can create a set and we can perform, if we have two sets, let's say set A and set S, we can perform the set operations like union, intersection, and other operations on that set. Right? So now if you have if you have the set S, you will print S, right? And you see here 10, 20, we had this, right? Here you can see 20 is duplicated, it is twice, 30 is occurring twice. But if you print set yes, only the unique values will be shown, right? Okay. So automatically we don't consider the duplicate value because S is a set and duplicate values are neglected, you see here. But if you are trying to access the contents of the set by using the index, you will get an error. This error you will get. Okay. So now let's move to another important data type called as dictionaries. So Python dictionaries. So what are Python dictionaries? So dictionary is a key value pair, right? So you see this D is a dictionary. So this A is called as key, and this apple is called as the value, right? So the dictionary is stored in this format. So this is key and this is value, right? So key is A, value is apple, right? So similarly key is B, value is bat, right? So on and so forth. So dictionary is created as key value pair. So you can access the value by using this key. So if this D is a dictionary, D of A means in the dictionary D, get me the value whose key is A. So this will return as apple. Right? Okay, so the conversion in data types. How can we convert one data type into other? You see, we have here 5, right? 5 is an integer, but if we say this is also called as typecasting or type conversion, right? So this 5 was integer, but if you want to convert that into float, simply write float 5. Right? So this 100.5 is a float, but if you want to convert it into integer, simply write int 100.5. So you will get this 100, which is an integer. Similarly, this 20 is an integer. So in order to convert this into string, you simply say str20. So 20 will be converted to a string. So now, if the value which you want to convert is not compatible, right? For example, you see here this 10p. How can you convert this 10p into integer, right? Because this p, p is a character, so I cannot convert this character into a string. That's why you will get this invalid literal for int, right? Okay. So now let's see where this is useful. This typecasting is useful, right? Let's see that. So let's say we have this example here. We have this user as master and lines 1000. So let's say I want to print this line. Congratulations, user is master. Congratulations, masters. And I want to see what is happening here. This is a string. We are concatenating this string with this string, right? User is a string, right? So strings can be concatenated by using this plus operator, right? So and then this string is concatenated with this string. But now if I directly write, rather than writing this, if I write only lines, right? So lines is the number. It's a number. So I cannot concatenate number directly with the string. So what will I do? I'll first convert that number into a string, and then I'll concatenate that string with the string already I have here, right? So that's why this string concatenation. So this will print congratulations master, you just wrote 1000 lines. Had this been only line, we would have got an error, right? So because this lines is now a string, see, the value is not changing, but the type is changing. The type of lines is now a string. So we can concatenate this string with other strings like this one and this one. Okay. So now let's see more things. So here, let's say we can convert one sequence to other. So we can convert a list to a set. For example, we have this list A, then type of A will be a list because it's a list. So now when I want to convert this list into a set, I will simply say set A, right? A is getting converted into set. Now if you print the type of test, you will get set. Right? Now how can I convert a string into a list? So we have, let's say, string this hello. I simply say list of hello. I'll simply say list of the string. So this string will be converted into a list, right? So now this is hello is a list, 0 location, 1 location, 2, 3 and 4, right? So that is how we can use variables and data types.